In this video, we'll be going over valid anagram. So given two strings s and t, return true if t is an anagram of s and return false otherwise. In our first example, we're given the strings s and t, and s is equal to anagram and t is equal to this string, which contains the same characters from anagram, but it's just in different order. So we can return true. In our second example, we're given the strings rats and car. We can see that the character c is not inside rats, so we had to return false. Let's go over the dot process. So let's first go over the definition of an anagram. So two strings are anagrams if they have the same characters, but the position of the characters may or may not be in the same order. This means we can keep track of the frequency of each character inside s and t. Then if the frequency of each character is the same, then we know that both strings are anagrams, or the two strings are anagrams. And in this problem, we are only dealing with lowercase characters. This means we are only dealing with lowercase characters. We can create two arrays with size 26 to keep track of the frequency of each character. Then after we find the frequency of all characters, if the arrays are the same, then we know the two strings are anagrams. Now let's go over the pseudocode. So we're going to create two arrays. Let's call it C1 and C2. And both of them have size 26. Then we're going to iterate through the indices of s, denoted as I, and then increment the frequency of the character currently at index I inside s at C1. And we'll do the same for t, and then we're going to perform the same operation for t, but using the array C2. Then we're going to return true if C1 is equal to C2, else we can return false. Now let's go over the time and space complexity. For the time complexity, we get O of n. Actually, we can actually validate the input parameter first to make it easier. So let's validate the input parameter. If S1, if S does not have the same length as T, then we can just return false. Now for the time and space complexity, we get O of 2n equal O of n, where n is the length of the input array, or the input string. So we find the frequency of characters inside s and t. In our space complexity, we get O of 1 because our arrays are constant, or size 26. Both of them is size 26, so it gets reduced to O of 1. Let's go over the code. So let's first validate the input parameter. If s.length is not equal to t.length, we can just return false. They are not anagrams. Then we're going to return arrays.equals. Then we'll get frequency of the character inside s, and then get frequency of the characters inside t. We're going to create a helper method. This will prevent duplicate code. We're going to create an array count to keep track of the frequency. Then we're going to iterate through the indices of the string, And then we're going to increment the frequency of the current character. Do not forget to minus A to offset it. Then we can return count. Let me know if any questions in the comment section below.